Okay, here we've got a cubic polynomial. Show that 2x minus 1 is a factor of f of x. We need to be thinking, how do I show that? And I would go with the quick way and use the factor theorem. So try, like, the root of this would be, if it was equal to, if I factorized it and said equal to 0, the root would be a half, so I'm going to try f of a half. It does say show detailed reasoning, so I'm expecting to get 0, but I need to show where that's coming from. So I'm going to cube a half, which is 1 over 8, so it's going to be 4 over 8. Square a half, which is 1/4, so it's 4 over 4. Then it's going to be plus 7 over 2 minus 5, so it's going to be a half, plus 1 plus 2.5. Actually, sorry, that's not 2.5, 3.5. 7 over 2 minus 5, and that's enough for me to say it's equal to 0. Therefore, 2x minus 1 is a factor by the factor theorem. I think it's a good idea to just say what you're using, so how can you jump to that conclusion. That was quite quick. You could have done long division to start with and got 0, and then that would be enough. Sometimes that's it's just a bit more effort than you normally need. So for 2 marks, you sort of think actually that's enough. However, we are going to have to do long division in part B. So sometimes you might argue, what, just get on with it, just do it in the first part, because the second part's saying, hence solve this equation. It seems like suddenly a step up for 7 marks. What's going on? But if we look at it, we see they're very similar equations. So we're essentially solving this cubic, but with a substitution. So I think a good idea is to just sort out the quadratic, the cubic, before we deal with the sign bit of it. So I'm going to divide. I'm going to do 2x minus 1 into, really bad, stop, there we go, that's a bit better. Okay, into 4x cubed plus 4x squared plus 7x minus 5. And it's just the normal algorithm. How many 2x's go into your first term? It's going to be 2x squared. Multiply back through minus them, 6x squared. Bring down the next one. 2x is into 6x squared, 3x. Multiply back through. Okay, we know we're going to get 0 at the end. 10x bring the minus 5 down. 2x is into 10x, go plus 5. Multiply back through. 10x minus 5. Brilliant. And we've got 0. So f of x equals 2x minus 1, 2x squared plus 3x plus 5. And we're going to be solving this thing equal to 0 in a minute, just the fact that x is going to be sine theta. It's probably worth thinking about all the solutions to this. If f of x equals 0, x equals a half, and then we need to think about this one here, but actually this does not factorize nicely, and the reason is that it doesn't have any solutions. B squared minus 4ac here is going to equal 9 minus 4 times 2 times 5, which is 40. And so this is going to be less than 0. So no solutions. Okay, so if we jump, like this is sort of you know, it's going to help us. I haven't actually even spoken much about this sign question moment. Okay, so if we want to solve this, okay, I'm going to basically now use all the things that I've been saying. So I can say this implies that 2 sine theta minus 1 times 2 sine squared theta plus 3 sine theta plus 5 equals 0. All I've done is replaced all my x's by sine theta. This is my substitution. This has no solutions, and you could say C above, but like right there, we've already shown it. So basically, sine theta is equal to a half. So theta is inverse sine of a half, which is 30 degrees. Let's just remember the graph though. The graph looks like this. I'm interested in all solutions between 0 and 360. So I've managed to get this one here, but there is also this one here. And because this is 30 degrees away from 0, where x is 0, this is 180. By symmetry, this is going to be 30 degrees away from 180. So the other solution that we need is 150 degrees. But there are actually only 2 solutions to this cubic with this trigonometric, the hidden cubic that is related to trigonometry. Often you get lots of solutions, but it's been designed in such a way that you can get 2 solutions, but still quite a bit to do there for those 7 marks. Different places to make mistakes, but those are the answers: 30 degrees and 150 degrees.